So let's go ahead and do one last example of trying to verify an argument using the different inference rules that we have learned so far. So consider this following claim right here. For all real numbers a and b, if 0 is less than a is less than b, then a squared is less than b squared. Okay, this seems like a perfectly fine argument to try to analyze. We have a hypothesis right here, all real numbers a and b. And then we have a conclusion right here, and our conclusion is an implication. If this inequality here is satisfied, then we get this other inequality. So if we wanted to try to use our inference rules to see if this is a valid argument or not, we would again have to apply our first step to translate this into a form where we can apply our inference rules. So let's go ahead and do that translation right now. So in doing my translation, the first thing that I see is I'm talking about real numbers a and b right here. So I should probably have a predicate function that stands for something being a real number. So I'm going to let r of x stand for x is a real number. And then I see, well, if an inequality right here, and this inequality involves both a and b. So my predicate function in this case is going to have to involve two variables right here. So I'm going to call this, let's call it L, because I see less than signs right there. It's going to have two variables, x and y, and it is going to be the claim 0 is less than x is less than y. A perfectly valid predicate function right here. If you plug in specific values of x and y in the domain, this right here indeed is a proposition. So this is a proposition function. Next, we have this inequality right here. It again involves two different variables. And so let's go ahead and call this one, let's call it S, because it involves squares right here. And so that'll be a proposition function. X squared is less than y squared. So if I were to take this English statement right here, use these proposition variables that I've defined, let's go ahead and translate this down into a way where we might be able to apply our inference rules. So then our argument really becomes the following. Okay. For all real numbers a and b, so making an assumption that I'm only talking about real numbers. So our first hypothesis is that a is a real number. Our second hypothesis is that b is a real number right here. And then my conclusion is that if this inequality is satisfied, then that inequality is satisfied. And so that's my conclusion. Okay, so, well, it looks like in a format that I could apply inference rules. But unfortunately, if I go back to Rosen and I look at tables 1 and table 2, it doesn't actually look like there are any inference rules that I could immediately apply to this. Because indeed, our hypotheses and our conclusion right here don't really fit into any of the inference rules that we've looked at so far. And this actually motivates for us why we need to consider proofs and different proof techniques. Because while inference rules are nice, very small ways to represent valid arguments, it doesn't encompass the entirety of all the ways that you might make a valid argument. So remember back in the very introduction of this entire section, I gave this kind of example where we had some pseudocode and a proof. And we sort of compared between the two of those things. You might recall that it looks something like the following. We had this right here. We had an analogy between how pseudocode and proofs kind of work. And with our inference rules, we have been looking at different ways to look at basically proofs of different arguments. Indeed, when you are presented with an argument, we are trying to show that our hypotheses imply that our conclusion is true. So what we're trying to do is show that our hypotheses imply our conclusion is true. And so our different inference rules were ways to look at proofs of Q of X, ways to derive valid conclusions from hypotheses over here. So while inference rules were some different ways to be able to do this, similarly to when you write actual code, these instructions right here, there are a bunch of different tools in your toolkit. There are a bunch of different algorithms and data structures and design decisions and various other tools in your programming toolkit that allow you to make different instructions to get your code to output whatever thing it is you're trying to output. Similarly, there are many more different proof techniques than simply our simple inference rules that were discussed in Rosen section 1.6. So that's why we're going to be transitioning to proofs and different proof techniques. Because while inference rules are perfectly valid and very fine and very useful, they are only a small subset of the tools that you can use to prove statements right here. And so we want to expand our different tools in our toolkit, similarly to how when you're looking at a programming language and trying to learn it, you would look at different examples and read the manual and instructions and etc. and stuff like that to get more tools to be able to populate these instructions right here. So that's why we're going to be transitioning to proofs and proof techniques. Expand our toolkit from simply simple inference rules.